Okay, all of you, welcome back. Uh, when we started machine learning, in the beginning itself, I was like explaining machine learning algorithms. Broadly, it can be classified into three types: supervised learning, unsupervised learning, and reinforcement learning. Uh, whatever algorithms you have studied so far, it may be decision tree algorithm, naive-Bayes, artificial neural network, KNN. All these are examples for supervised learning algorithms. Okay, so far we have just studied about supervised learning algorithms. Today we shall see unsupervised learning algorithm. Okay, what is the major difference between supervised and unsupervised learning is in supervised learning we'll make use of labeled data. In unsupervised learning we'll just use data like unlabeled data. We have the data, but we don't know like its classes we will not be knowing. Okay, that is the difference between supervised learning and unsupervised learning. So in supervised learning, for example, if this is the data set, you can see here iris data set again. Uh, if I am applying supervised learning algorithms for this data set, then I will be having only these data. These classes will not be there. Like iris, which class plant it is, it will not be there. See, this is the label for this data. This class, whatever is there, iris, setosa, versicolor, and virginica. These are the classes of the plant. That is, this data can be classified into three classes. These are the labels. So labeled data means if you are applying the algorithm, if you have the labeled data, then most of the cases we'll use supervised learning algorithms. But if you have the data and if you don't know the class of the data, labels, then that's unlabeled data. Then we'll make use of unsupervised learning algorithm. One such unsupervised learning algorithm is K-means algorithm. Okay, clustering. Clustering is an example for unsupervised learning. Uh, so your eighth lab program is apply K-means and EM algorithm to cluster the data into different categories and measure the performance between K-means algorithm and EM algorithm. Okay, EM and K-means are the two algorithms which are example for unsupervised learning. So eighth lab program is to apply these two uh, algorithms for the given data to perform the clustering. Okay, once it is done, you need to find out the efficiency of these two algorithms and you have to compare them. That means you have to write the conclusion which algorithm is better among these two. Okay, so which is better. So that is the eighth lab program that is based on clustering. So clustering, you might have heard about the word clustering. Clustering is nothing but grouping the items which are related to each other. Okay, the data points which are close to each other, we'll group them as one cluster. So clustering overall means we are like the data items or the data points which are very close to each other, which are near to each other, we'll make them as one cluster. So similarly, all the related items will be in one cluster, and the items which are in one cluster will be far away from the other clusters. Okay. For that, what we'll do is first thing is uh, we'll measure the distance between the data points and the centroid. We call it as centroid. We'll measure the distance, and the if there are three centroids, the points whichever are close to that centroid will belong to one cluster. Okay. If there are four centroids, we'll calculate the distance between data points and that particular centroid. The data points, whichever are close to that centroid, will make that cluster. Okay, that is how clustering is done. Okay, randomly we'll select two or three points in the space and we'll start calculating the distance between that centroid and the given data points. The points whichever are close to that centroid will make one cluster. So clustering algorithm, K-means and EM are two algorithms uh, which we are using. And again, we will we are not going to implement these two algorithms. Straight away, we'll use the library uh, which is available in sklearn and we'll do the clustering. Okay. Again, starting 4 5 lines, you can see here. This will be there in all the programs where when we are importing certain libraries. So first line you observe, import matplotlib.pyplot. So see, matplotlib is a library or package which is related to the graphs, okay, or diagrams. If you are asked to plot any graphs or diagrams in your program, then in Python we'll make use of this library matplotlib. Okay, that is very important. Whenever we talk about graphs and diagrams in the Python, we'll make use of this matplotlib. Okay. Next thing is from sklearn import data sets. We need data for our program. Again, from the sklearn library itself, we are going to import it. Okay. Parallelly, I'm executing this program line by line. Okay. Next is from sklearn.cluster. See, KMeans is a clustering algorithm. So sklearn.cluster import KMeans. So KMeans API I'm importing. Again, observe K is capital, M is capital, remaining things are small letter. Okay, KMeans algorithm. Import sklearn.metrics. As I said, you need to measure the performance of these algorithms. So we need metrics. So accuracy score, that is the one thing we are going to measure. So import sklearn.metrics as SM. So wherever you want to measure the accuracy, just use the SM.accuracy score. Okay, from sklearn, import pre-processing. See, EM algorithm, as I said, to implement that algorithm is not available directly in the package. So what we'll do is Gaussian mixture function we are going to use, which will do the same task as EM algorithm. EM is not exactly an algorithm; it's a procedure. Okay, that we are going to do with the help of this Gaussian mixture function. For that, pre-processing is required. So we are importing pre-processing and then Gaussian mixture function. Import pandas as PD. Pandas the library, we need pandas because if you are using data frames in your program, data frame is a data structure which is defined under pandas package or library. Is it clear? So we are importing pandas and then import numpy as np. Arrays, if you are using arrays in your program, we need numpy because array is not an inbuilt data structure in Python. If you are asked, supposed to like if you want arrays to be used in your program, we need a numpy library. So data frames, if you want in the program, we need pandas. So import pandas as PD and numpy as np. So iris is equal to datasets dot load iris. See, I told you in the previous when I started to explain this program, I mentioned that for unsupervised learning, we'll use unlabeled data. If you have labeled data, we'll use supervised learning itself. But iris data set is a labeled data. Because here we have the labels. This is the data set. We have the labels, iris data set. Still, why we are, although this is an unsupervised learning algorithm, why we are using, you may ask why we are using iris data set itself. The only reason why I'm using Iris dataset is because it's a well-defined dataset, uh, and I just want to keep it uniform, same dataset. So I'm using for all the programs. What we can do is in this dataset itself, we shall remove these labels. Only we can keep this data. Labels are not required. Okay, we shall remove this label and then we can use in the program. That is what we are doing in the program. Although it is Iris is a label data set, we'll remove all the labels. We'll just use that data. Okay. So Iris is equal to load dataset dot load Iris. See, that Iris, whatever we have extracted from the library, it is not in the data frame format. So I'm converting it into data frame format. So temp is equal to pd dot data frame of iris dot data. Okay. In the iris data set, only data I'm taking and that I'm storing it in the form of data frame, which is present in the library temp. Now, if you see the temp library, temp variable, you can see here, okay, temp I have loaded. So this is our data. There are no labels, only values. Okay, temp, 150 rows of data, only data. There are no labels. See, this is what we want. Only data we need without labels. So in temp, we have only sepal length and width, petal length and width. Only that much is up. Okay. So that data is present in now. Now that values are present in temp. Next thing is temp dot sample fraction of 1 that I am assigning to x. Okay. See, if you observe this data set, Iris setosa, see this data set is in one particular order. Okay. Uh, first, one type of plant class, second, another type of class of plant, and third, another type of plant class is present. See, data should not be in one particular order. Okay, it has to for training, testing. Every data has to be mixed well. So this temp dot sample, what it will do is it will shuffle all the data. Okay, temp dot sample, what it will do is it will shuffle this entire data. See, class one, class two, class three, it is in one particular order. So it will shuffle all this data. It will mix the data. That is what this line will do. X is equal to temp dot sample. So we are mixing the data. But now it is not in one particular order. So in X, we have the data. Okay, in X, we have the data. I will just plot the graph and see how data is present. Say I have plotted the graph for the data available. You can see here, this is the graph for our data. Okay, this is the graph for our data, sepal and petal. Uh, See, there are three classes in this data. Okay, uh, three plant classes, and if you observe here, three dots, red, black, and green dots. So all the data for sepal, I have plotted one graph, scatter graph, and for petal, I have plotted one graph. If you observe here, all the dots are overlapping each other. Okay, everything is overlapping here. Here also, everything is overlapping. All the data is overlapping one another. Clustering means, as I said, all the related items will be grouped into one cluster. So our plant has got three classes. So if you apply the clustering algorithm for this data, what is the end result you should get? You should get three cluster of data, all green dots together, black dots together, and red dots together. Okay, it has to group the related items together. So if you apply the clustering algorithm for this data, see this is the graph before applying the algorithm. Okay, I have just to see how data is scattered. I have plotted this graph. Before applying the algorithm, data is scattered everywhere. Green is overlapping with red is overlapping with black. They are overlapping with each other. So if I plot the same graph after applying the K-means algorithm, all green dots should come together, red should come together, and black dots should come together. Okay, so that is what our clustering algorithm will do. So just these are the details how to plot the graph. X dot columns is equal to, I'm saying what are there in the column. See, our x is nothing but, 1 second. X is nothing but, capital X is nothing but our data. So this is our data. It has not got the column names or anything. Now I need to put the column names so that it will be easy to represent it in the form of graph. So I'm giving the column names for this data. Columns is equal to sepal length, sepal width, petal length, and petal width. If I execute this line, and now if I check what is there in the X, you can observe the column names has been given to this data. Okay, sepal length, sepal width, and petal length and petal width. And then I need Y. Y is nothing but targets, those three colors, those three classes of the plant. So plot dot figure size, this entire graph size, I'm saying 7 by 7. You can give any length to this, any values 4 by 4, 5 by 5 like that. And then color map is equal to np dot array. Those red dots, three class of data is there. What I'm saying is uh, red, lime, and black. You can give some other colors, blue, all those things you can give here. I'm just giving these three colors. So subplot for petal one graph and for sepals one more graph. Subplot how many rows? One row, two columns, and the first graph is for sepals. First row, second column, one row, two columns. Second graph is for petals. Okay. S is equal to 40 or 50. That is the thickness of those dots. You can change that. Okay. You can change those values. So we are plotting the graph sepal length, sepal width for that, and petal length and petal width. And target, white or targets means that red, blue, and all three classes. So these set of lines you have to execute together. To execute the lines together, you select those lines and then you press this execute. Say I have increased the density of those points. This is the graph. Okay, before applying K-means algorithm, I have plotted this graph. So points are scattered like that. Next thing is I'm calling K-means algorithm. Okay, model is equal to K-means, and I know that our iris dataset already we have the knowledge that this iris plant has got three classes. So I'm saying that in my K-means algorithm there will be three clusters. I'm defining the cluster. So for which you are applying the algorithm for our data X. Okay, model dot fit. We are applying the algorithm and score we are trying to find out. Accuracy score in Y we have the actual result. Once you apply this algorithm, K-means algorithm, the predicted values will be present in an internal label called as model.labels underscore. See, this is an internal variable. Okay, model is our function which we are calling through K-means model.labels underscore. So the labels, whatever it has assigned to our data points, it is present in labels underscore. Okay, the labels whatever you have defined. To find out the accuracy, you need actual labels versus predicted labels. So once accuracy is it is present in score, again I want to plot the graph and check how the graph is plotted for the after we have applied K-means algorithm. See, we have checked how graph appears before K-means. Now I want to see how graph will appear once you have applied the K-means algorithm. So you can see the result here. This is real classification. That was this is what we have seen before, and this is K-mean classification. Okay, so now from the two diagrams you can observe all red dots are grouped together, all green dots are grouped together, all blacks, and somewhere blacks and greens are overlapping each other. Okay, so this is clustering is happening here. Here, this is real classification. Before clustering, I'm plotting two graphs before clustering, and this is after clustering. You can easily notice all the points which are related to each other are grouped together. And this is not such an efficient algorithm. You can see here efficiency, it is showing 40%. Okay, so green and black dots are overlapping. They are not that accurate. So these points are overlapping. But red and green things are grouped together. But these points are overlapping. Here, nothing is overlapping. Here, everything is overlapping. Before clustering, and this is after clustering using K-means algorithm. Efficiency, it is 40%. Is it clear? So this is for K-means algorithm. See, if you keep running this algorithm, its efficiency will change. Okay, sometimes it will improve. Sometimes here you can see now it is decreasing. Since that's the problem with K-means algorithm because it always starts with a random centroid selection. For that reason, its efficiency varies. But with each execution, it should improve. You have to execute it until you get at least 40% of accuracy. Okay, that is K-means. Next, we shall apply EM algorithm and see. We have taken a variable scalar. First thing is we have to do the pre-processing to the data x. Okay, x dot fit, and then call Gaussian mixture. Number of components 3. Okay, 3 clusters as I said, and then dot fit. Dot fit means you are applying the EM to this data, and then do the predict of x's. So predicted value is present in y underscore cluster underscore GMM. Accuracy score you need to find out between actual data and this predicted labels. After that, again we need to plot the graph same as before. Now I will plot the graph, all three graphs together. You can see, okay, so this is the graph before classification. This is the graph for K-means classification. This is the graph for EM classification. Accuracy of K-means is 0.366, that is 36%. Accuracy of EM is 35%. Okay, clustering, easily you can see all the green dots completely they are separated. Okay, they have been made one cluster. Red also almost, and but black dots are overlapping. Okay, efficiency of this algorithm is also not that better. All are because see our data itself is like that. For our convenience, we are using the same data. So for this data, we can say that efficiency of these two algorithms are not that good. Okay, for this given data, it is not giving that good result. These two algorithms. In lab program, they have asked compare these two algorithms. So what comparison you can write here? What you can write is when we compare the accuracy of these two algorithms, accuracy of K-means algorithm is better than accuracy of EM algorithm. Okay, so we can say that K-means algorithm is efficient than M algorithm. Is it clear? Okay, efficiency of K-means you can see it has reached almost 41%. This is 35%. So for this particular data set, efficiency of K-means is better than M. So we can say K-means is a better algorithm compared to EM. Is it clear? So that is about clustering, uh, lab program number 8. While writing the output for this algorithm, you have to write accuracy, these two things, and you have to plot these three diagrams before classification, K-means classification, and EM classification. Is it clear? Okay. Uh, Tomorrow I will do remaining programs. Okay. For today, I'll stop here. All of you mark your attendance in the chat. Okay. Yeah. Thank you. ಇದು ಕಾಲೇಜಿನ